Hi guys, today we're going to be talking about the domain of compositions of functions. Now, in our previous video, we discussed what compositions of functions really were. It's linked in the description in case you want to review. So now let's talk about the domain of them. So we'll start off with two functions, f of x and g of x. Now the composition of these two is f of g of x. Now, how do we find the domain of this? Well, first, there are multiple steps, but let's start with our first step. First, we find the domain of g of x. Now, why do we do this? Well, when we're evaluating compositions of functions, we first evaluate g of x, because that is where our x value is going. It is going into g of x, and then whatever this is equal to, we'll say it's equal to v. This value of v is going into f of x to get our answer. So this is the pathway of how we get to our answer. And notice the x starts off at g of x. So if x is not in the domain of g of x, it is not in the domain of f of g of x. Now, this can be slightly tricky sometimes. So let's look at a very specific example. Say we had f of x equals x squared and g of x equals the square root of x. Now f of g of x, well, that's just the square root of x squared, which is just x, right? Well, sort of. Remember that our x value is going to g of x first. So if x is negative, then g of x is not defined because the square root of x cannot take in negative values. So f of g of x is equal to x, but only when x is greater than or equal to 0. So this is an example of a specific case where we have to take into account of the domain of g of x when determining the domain of f of g of x. So now that we've determined the domain of g of x, we've passed checkpoint 1. And we get a value, and now we have to go to f of x. Now, if this value is in the domain of f of x, then we win. And otherwise, we have to find a new value. So let's look at an example. This time, let's say f of x equals the square root of x, and g of x is just equal to x plus 1. The domain of g of x, that's all real numbers, so we don't have to worry about anything. So f of g of x is square root of x plus 1. So now we want to know what values can x plus 1 be such that it is in the domain of f of x. Well, the domain of f of x is all x greater than or equal to 0. So for this problem, is it going to be all x greater than or equal to 0 for the square root of x plus 1? Well, no, it isn't. I could have x as negative 1 in here and it's still defined. So when we go back and look at f of x equals the square root of x, we note that all we really want is for x to be greater than or equal to 0. Now note in f of g of x, that means g of x is our x in this expression, which means g of x is greater than or equal to 0. Which means the square root of x plus 1 is greater than or equal to 0. So x is greater than or equal to -1, and that's our domain. So remember that in f of g of x, our x is actually g of x, not just the variable x. And if we pass this checkpoint, then we get an answer and we win. And this is the series of steps we take to determine the domain of compositions of functions. So now that we've done this, let's try a few examples. I have f of x is equal to 1 over x, and g of x equals 1 over x plus 1. And we want to determine the domain of f of g of x. First, let's find the domain of g of x. The domain of g of x is going to be all real numbers except when x is equal to -1. Because when x is equal to -1, we get a 0 in the denominator, and we do not like that. We do not want zeros in the denominator. So now, let's find f of g of x. F of g of x is 1 over x plus 1, which when we simplify that, that's just x plus 1. Now this would usually have a domain of all real numbers, except remember, g of x cannot take in the value of -1. So therefore, the domain of f of g of x is all real numbers except -1. Domain of compositions of functions is really just that.